Okay, so in the last lecture, we have started with RLC series circuit analysis, and we have completed the case for XL greater than XC and XC greater than XL. For both the cases, we have drawn the phasor diagram, voltage triangle, impedance triangle, and power triangle, and we have seen the various expressions. And in the last lecture, we couldn't complete this, but we have written the thinking process. So let's start with numerical number 1, then we'll move on to lecture number 22. Okay, so already you have written the statement, right? You have to directly start with a numerical and revise. RLC values are given. We need to find circuit impedance Z, circuit current I, power factor, active, reactive, and apparent power. So first of all, we have to find the circuit nature. So you will say it is a RLC circuit. So whether it is a capacitive or inductive. So let's start writing. So for the first case, what we need to calculate first? XL and XC. So find out XL first. XL is 2 pi FL. 2 pi into frequency is 50. So 2 pi 50 into L is how much? 0.1. So calculate XL. We have to be quick. Write along with me so that we can cover more numericals. Is it 31.42 ohms? Similarly, calculate XC. XC will be 1 upon 2 pi FC. That will be 1 upon 2 pi into 50. What's the value of capacitor? 50 microfarad. So 50 into 10 is to minus 6. So please let me know the value of XC now. XC will come out to be 63.66. Right? Some of you have solved this or what? Okay. Great. So if you compare XC and XL, which is greater? So since XC is greater than XL, what can we say? The circuit nature is capacitive. Okay. You find capital X. That will be XC minus XL. So what will be this? 63.66 minus 31.42. That will be 32.24 ohms. What is X called as? Net reactance. Net reactance of the circuit. Okay. So this is called as actually net reactance. Now, how will you find, as we have said, XC is greater than XL. So your nature of circuit is capacitive. Okay. Remember, phasor diagram for all. Like we have done the circuit for only R, only L, only C, then RC, RL, then RLC. Phasor diagram should be thoroughly followed. You should understand that very, very clearly. Alright. Now, what is my V bar? V given as? What is my voltage given as? 200 volt. So how will you write it in the polar form? 200 angle 0. Correct? Yes or no? And then how will you calculate? Next is how will you calculate Z? What is the general formula for Z? In rectangular form, R plus minus JX. Correct? So whether it will be plus or minus, it will be minus. Why? It is capacitive. So what is R value given as? So write down Z bar is equal to what is R? 20, right? Minus J, what is X? 32.28. Got it? So convert this into polar form. So what will you do in your calculator? In your calculator, press shift polar and substitute 20 comma minus 32.24. What answer you will get? Let me know. Are you getting 37.94 angle minus 58.19 degree, right? Now, why are we calculating Z and V? So that we can calculate circuit current. This is what was asked, right? Z. So this is my circuit impedance. So out of this, what is my polar form of Z? Z bar, Z angle phi. So from here, what is Z? 37.94 ohms. And what is phi? Minus 58.18. Negative sign indicates that the circuit is capacitive. Last lecture we have talked about analysis of a general series circuits, right? In that we have said. Okay. Now that we know that that we have the value of V and Z, can we calculate I? What is V given by? V bar given by I into Z, correct? So what will be I given by? V bar upon Z bar. So what is V bar? 200 angle 0 and Z in polar form is 37.94 angle minus 58.19. So you can easily divide that. Current will be 200 divided by 37.94 will be what? 5.27. And this angle will just come up and it will become plus 58.19 degree. So this is my current. Got it? Next, what we need to find out? Power factor, right? Power factor will be, are you understanding all the steps? Please write along. If you are not following anything, ask me immediately. You all got up till here? Now calculate power factor, which is cos phi and cos of minus 58.19. Cos theta is cos minus theta. It doesn't matter whether angle is positive or negative. So let me know the answer. 0.527. Leading or lagging? Leading. In case of a circuit is capacitive, power factor is leading. Now next calculate all the three powers, P, Q and S. So what will be the active power? P, VI, cos phi. So V is around, how much is the V value? 200, no? How much is V? 200 RMS value. How much is IRMS? 5.27. And how much is cos phi? 0.527. Please do the multiplication of these three numbers and tell me the answer. Q will be similarly VI sin phi. And then what is this? Apparent power will be V into I. So please tell me the multiplication of these three. Phi watts. Okay. Q value 200 into 5.27 into sine of minus 58.19. Minus 895.69, right? What's the unit? VAR. Volt ampere reactive. And what is 200 into 5.27? 1054. V into A. Write the unit properly, okay? So these are the units. This is a unit of active power. This is a unit of reactive power. And this is the unit of apparent power. Alright? So this was the numerical which was left in yesterday's lecture. Now that we have completed it. Completed all the steps? Can we move on to the next one? Are you doing the calculations? Alright. So let's start with the next one. Right now numerical number 2. So now we are starting with lecture number 22, 27, 9, 23. So write down numerical number 2 statement. For the circuit shown below, this is numerical number 2 for series RLC circuit. So write down for the circuit shown below, calculate first circuit current. That means we have to calculate I. Second, calculate V1 and V2. I'll let you know what is V1 and V2. First, let me draw the diagram. So this is my circuit. Kindly draw along with me. So this voltage is 200 volt, 50 hertz. This is R1, L1, R2, L2, C2. Let me show you the bifurcation. This is V1 and this is V2. Alright. If this is my circuit current, let me represent it as current I, AC current I. Can you tell me what will be this first part over here? This will be impedance. Let me call it Z1. And let me call this is RL network, and this is RLC network. This is Z2. Okay? Z2 impedance is RLC again. And the values are also given. The value of R1 is 10 ohms. The value of L is 0.05 Henry. Value of R2 is 20 ohms, 0.1 Henry, and C2 value is 50 microfarad. Alright? I'll give you a few seconds more to draw. Then we'll think about the thinking process, how we will solve it in a flow. Completed? Yes? So what are we supposed to find? V1 and V2. What is V1? Voltage across R1, L1 together. That is Z1. And V2 is voltage across R2, L2 and C2. That is Z2 impedance. Okay. So we'll talk about the thinking process. So tell me what will be the first step? What will be I given by? I will be, if you know total Z, total V. Do we know total V value? Yes. Total V upon total Z. How will you calculate total Z? Total Z you can calculate once you know Z1 and Z2. So you first calculate Z1 and then calculate Z2. Okay. Next step is if you and what is Z then? Z1 plus Z2. So once you know the value of Z1 and Z2, can you find V1? What is V1 given by? I into Z1, correct? And V2 will be given by I into Z2. Alright. Also, we need to determine the circuit nature, whether it is capacitive or inductive. Okay. This is the thinking process. No need to write this. This is how we will proceed. Okay, let us start. Understood what we need to find? Okay. So let us begin over here. Please write along so that you don't lag behind. Solution. So we need to find first V1 and V2. So first step is we'll write V in polar form. What is V in polar form? 200 angle 0 degrees volt. Agree? What is the total resistance of the circuit? Can you tell me? Total R. It is R1 plus R2, correct? That will be 10 plus 20, that will be 30 ohms. Total resistance of the circuit, right? They are all connected in series. Now, calculate XL1 and calculate XL2. You cannot add, see, if you are thinking like we have added resistance, we can add inductance also. Wrong. You cannot add. What can you add? You can add XL1 and XL2. You cannot add L1 and L2. Are you getting it? So first calculate XL1 and XL2. So this will be 2 pi L1. This will be 2 pi F L2. So frequency is 50. So that will be 100 pi into L1 is how much? 0.05. How much this comes out to be? 15.71 ohms. Then this will be 100 pi again into 0.1. That will be 31.42 ohms. Now can you calculate total XL? Yes, now inductive reactance we can add. So you can write XL will be XL1 plus XL2. So calculate total XL. How much will be that? 31 plus 15.71. That will be 47.13. Just check. So far it is clear. Okay. Why we are not finding XC1 and XC2? Because in first C1 to hai nahi. So we just need to find XC2 only. Got it? So find XC only. XC or XC2. So XC will be 1 upon 2 pi FC2. 1 upon 100 pi. What is C2 given value? 50 into 10 is to minus 6. We have calculated this number before, right? It is 63.66 ohms. So what is XC? 63.66 ohms. Now did you understand? Now you can compare. What is total R of the circuit? 30. What is total XL? 47.13. And what is total XC? 63.66. So which is greater? Yeah. So what will you write? As XC is greater than XL, the circuit nature is capacitive. As XC is greater than XL, are you understanding? No matter whatever you connect in the series, you have to calculate the net inductive reactance or net capacitive reactance. Got it? So as XC is greater than XL, circuit is capacitive in nature. Then calculate net reactance X, which will be XC minus XL. How much is that? 16.53 ohms. Please calculate X. Now you all tell me what will be total impedance. Tell me, circuit is capacitive, right? Can I represent impedance in rectangular formula? So Z bar will be R plus or minus JX. I mean XC minus XL, but I've written it X. So calculate this. R total R is how much? This is total R, not R1 and R2. So how much is that? 30, right? 30 minus J, 16.53. 16.53 is my Z. Now calculate that in polar form. So Z bar will be, what will you do in polar form? Shift POL, polar, in a calculator, 30 comma minus 16.53 and press enter. What did you get the value of Z bar? 34.25 angle 28.85. Right? Yes, that is it. What is the phase angle of the circuit? Phi? Yeah, this is phi minus 28.85. And this is what is this? Z. 34.25 ohms. Now, what will you do? You require circuit current. Now, what is circuit current? V by Z. So, I bar will be V bar upon Z bar. What will be V bar? 200 angle 0 and Z bar will be this 34.25 angle 28.85. So what is 200 divided by 34.25? It's 5.84. Yes, 5.84 angle plus 28.85. and this will be amperes. This is my circuit current. Now tell me, how will you calculate V1 and V2? V1 is I into Z1 and V2 is I into Z2. Have we calculated Z1 and Z2? No. We calculated total. Correct now? So we need to calculate individual Z1 and Z2 now. Are you understanding what we did? We have clubbed R together, we have clubbed L together, I mean inductive reactance together, and we found out the circuit nature is capacitive. And we have found out the general expression for Z. Okay. Now individually what I need to find out, I found out first step. So first step is clear. Now I need to find out Z1 and Z. So what is Z1? R plus J XL1. And what will be Z2? R minus or plus? Minus, no? Because XC is greater already, right? Or because XL2, XL is actually XL1 and XL2, right? So XL2 is very, very small compared to XC. So that's why again it is capacitive. So what will be the formula? R minus J XC minus XL2. Correct? So please calculate Z1 and Z2 now. You know where it is heading. So we need to calculate Z1. Z1 is R1 plus J XL1. Now tell me what is R1? 10. And what is XL1? We have calculated that. XL1 is 15.71. Convert this into polar form. 18.62 angle 57.52 degrees. So this is my value of Z1. Are you getting it? Achha, what will be Z2? See here. Z2 is R2L2C2. What is XL2? 31.42. And what is XC? 63.66. So circuit nature is capacitive. Again. So Z2 will be R2 minus J. What will come over here? XC minus XL. Na? So XC minus which XL? XL2. Okay, why XC? Because it is only one capacitor. So that's why it is called as XC. Now calculate this. What is R2? 20 minus J. What is XC? 63.66 minus 31.42. Just check. XL2 we calculated before. So Z2 will be 20 minus J 32.24 ohms. Convert this into polar form. Shift polar 20 comma minus 32.24. I told you you have to keep in your calculations. So this will be 37.94. Yes. Angle minus 58.18. So this is your Z2. Why I am calculating in polar form? Because I am going to multiply with I. V1 will be I Z1, V2 will be I into Z. So the final step will calculate. Now we have calculated Z1 and Z2. See the thinking process. Z1 and Z2 done. So this is done. Now V1 bar is I into Z1 and this is I into Z2. Why I is common? Series network, na series network mein current is common. So now calculate last step. I mean second last step. V1 is what? I into Z1. What is I? 5.84 angle 28.85. And that is multiplied with Z1. What is Z1? 18.62 angle 57.52. Now how will you multiply them together? The magnitude you multiply as it is. What about the angles? Angles get added up when they are multiplied. So 5.84 multiplied by 18.62, that will be 108.74, right? Angle, they get added up. So it will be 86.37. This is V1. Similarly, what will be V2? I into Z2. I is 5.84, angle 28.85, and Z2 we have calculated above, as you can see, 37.94, angle minus 58.18 degrees. So multiply the magnitude and add the angles. So this will be 221.57, angle minus 29.34 degrees volt. So this is my value of V1 and V2, which we were supposed to find out. Understood? That's why the thinking process is important. Rest is all simple only, no worries. However complex the circuit will be, you have to keep your basics correct. And writing over here is not enough. You have to go home and practice this thing. If you don't practice, you will lose away this thing. And you cannot cover everything before your ISC exam. So if you have not yet started your studies, start today only. You'll thank me later. Start today or else it will be too late. You don't have time at all. You think you have time. When you sit and study all together, there's a lot of stuff to cover. Module number 1, we have practiced enough. But module number 2, we are not at all practiced at all. So that is YOLO on your own there. Alright? You can see how big a numerical can be, and this will be only asked for 10 marks, not more than that. So you don't ever know what are you getting into. Next. Completed everyone? Numerical number 3. Please write along with me. A coil, see listen, I could have easily given you the numerical statement. But reason is why we are writing it, because we understand that also. So a coil. What do you mean by a coil? Remember, coil means inductance with a resistance. Inductor and internal resistance. So coil of 0.6 power factor, please write down the statement, of 0.6 power factor in series with a 100 microfarad connected to 50 hertz supply. The potential difference or the voltage, potential difference is also called as voltage. The voltage across the coil is equal to the voltage across the capacitor. Find inductance L and resistance of the coil. Actually, here should have written inductance. Find inductance and resistance of the coil. Now the challenging part is to draw the diagram. Diagram is not given, only this much is given. That's it. You have to draw the diagram from here. I guess you must have completed the numerical up till here. Completed up till here. Now, what do you mean by a coil? Now listen, you can write, but listen over here how to draw the diagram. What do you mean by a coil? I've already told you all. Coil means what? A small resistance in series with an inductor. And there is a capacitor also. So, that means we have this. This is small r. This together is a coil and is connected in series with a capacitor. So what does the circuit become as? Circuit has become a RLC circuit, right? This is my coil. Let me draw it bigger. Okay, this is my coil. So what are they asking? They are asking us to find this R and this L, right? This C is given to you, right? C is how much? 100 microfarad. Is the voltage given to you? No, it's V volts and 50 hertz supply. What else is given to you? This is current. Can you read the statement again? The voltage across the coil is equal to the voltage across the capacitor. What does that mean? Let's say, I'll expand it even further. If this is my voltage across coil, I'll write it as V coil, okay? And this is voltage across the capacitor. What is the meaning of the statement? VC is equal to V coil. Voltage across the coil is equal to voltage across the capacitor. That is the given data. And power factor of the coil is given. So this is the diagram. What is the given data? Given C is given 100 microfarad. Frequency is given. Power factor of the coil is given. Remember, 0.6, and V coil is equal to VC. What are we supposed to find? L and R. C is given, right? Now tell me, how will you proceed? To calculate L, think backwards. L कहाँ से मिलेगा? XL से. Okay, where do you get XL from? If you know the impedance of the coil, what is impedance of the coil given by Z coil is what? Small r square plus XL square. Alright. Power factor is given by what? Remember power factor का formula क्या था? R by Z. आगे नहीं? So यहाँ पे R is small r and Z is what? Z coil. Okay? And then when voltage of the coil is same as voltage across the capacitor, what can you write over here? Wait a minute. Let me write and show it to you. The mental picture is not working well. Okay, let me write it here in thinking. So first step is L is to be found out, right? You should know the value of XL because XL is 2 pi FL. Alright? Next step is we know Z coil square. What is Z coil square? RL circuit now. So RL circuit, how will you write it as R square plus XL square? So here it is R square plus XL square. Okay. Next is what is power factor of the coil? You remember the formula R by Z. So here it will be R by Z coil. समझ गया? So your power factor is given to you, right? So if you know Z coil, if you know power factor, you can calculate R. Yes. Next is V coil is same as VC. What is V coil given by? I into reactance of the coil, right? That is XL and I into XC. So from here you can calculate XC, and XC is what? 1/2 pi F into C. So here we can calculate XC because C is given to you. We can calculate XC and then we can calculate other things. So let's start. Matlab, here suno, we are going from bottom to top, meaning you have to start from step number 5, go to step number 4, 3, 2, 1. Ulta hai. Why we are going? Because we are going from what we want, and what we want from what we get, and what else we have. ऐसे find out करें, उल्टा जा रहे. So first step we find this XC. Understood this thinking process? You have to think this on your own. It will not help if I tell you. It should come on your own to you. Then these problems can be solved, dealt with easily. Or else you need to practice a lot. Only that is the alternative. The more you practice, the more numericals you will be confident. See, solving numericals, only 2 skill sets is required. Confidence and confidence. Both the skill sets are confidence. If you are not confident, you will definitely land up into trouble. So be confident in calculation, be confident in solving. So first step is find XC. 1/2 pi FC. F is given, right? F is given as 100, right? So 100 pi. 2 pi into 50. 100 pi. What is C? 100 microfarad, right? Yeah, it is 100 microfarad. So 100 pi into 100 into 10 raised to minus 6. Calculate and tell me this number. 31.83. So we have calculated one step. I told you, we go from 5, 4, 3, 2, 1. So let's go to the next step. What is the next step? V coil is equal to VC. So what is V coil? Over here in the diagram, voltage across the impedance is what? V coil is I into X coil and Z coil basically. And here VC is I into XC. Yes or no? Yeah, you're following? Okay. So let's proceed further. Uh, VC is what? Actually is ZHI, not X. I into Z coil and this is I into XC. What is known to you over here? I and I gets cancelled. XC is known to you. What do we get from here? That Z coil is indeed equal to XC, which is 31.83. So we know Z coil also. Is the power factor of the coil given? Yes. Is Z coil is given? Yes. Can you find small r? Yes. From formula number 3. Are you understanding what we mean by going 5, 4, 3? Now we go to step number 3. So now, power factor of the coil, how much it is? 0.6. What is the formula? R upon Z coil. So from here you can calculate R 0.6 into Z coil, which is 31.83. So calculate small r now. 19.1. Is it 19.1 approximately? Yeah. Now once we know the R, what is Z coil square? Small r square plus XL square. Right? So from there you can calculate XL and from there you can calculate L. So please complete the numerical. So next step is Z coil square is equal to R square plus XL square. So what we want over here, XL square will be Z coil square minus R square. Z coil is 31.83 and R is 19.1 square. So please calculate this number. XL square will be 648.41 and XL finally will be 25.46. Please tell me this answer. I'll wait. Are you following? The analysis of AC circuit with R alone, C alone, L alone, with series RL, series RC, series RLC. All the analysis you should know and you should practice them. Huh? Don't just refer the handouts. You need to write it down in your books. Okay? Now what is left out? Once we know XL, can we find L? Remember, in the entire process, voltage V was not given. Normally it is given, now here it is not given at all. So once we know XL, please find L now, which is very difficult, very easy, sorry. 1 upon, XL is 1 upon 2 pi FL, 2 pi FL. So L will be 1 upon, or XL upon. Yes, now, what is XL? 25.46 divided by 100 pi. Because frequency is 50. Calculate this. L 0.081 Henry. This is the answer. Okay? No one numerical is same. All are different variety. So complete this. Alright? Can we start with the next one? What numerical is this? Numerical number 4. Write down numerical number 4. A resistance R and inductance 0.01 Henry and a capacitor are connected, please write along, are connected in series. When a voltage V equal to 400 sine 3000 T minus 10 degree volt is applied to the series combination, the current flowing is 10 root 2 cos 3000 T minus 55 degrees amperes. Find R and C. Entirely different, I mean, in the context what we have studied. I and V are given, L is given, and we need to find R and C. So it's a RLC series circuit, right? So the diagram will look like this. We have R, we have L, and we have C. Okay, diagram is not of much help over here. Apart from that, only one information is given, 0.01 Henry. R and C we need to find out. This is I, this is V comma Hertz, and this is RLC. The total impedance will be Z. That's it. Now, is cos omega t standard form? No. You have to convert it into standard form. So, what is the thinking process? Convert I and V into polar form. Divide them, V by I, you will get Z. Once you get Z, you find the circuit nature. How will you find the circuit nature? By phi, angle phi. So the phi is negative, circuit is capacitive. Phi is positive, circuit is inductive. Okay? Then you find out Z. If it is inductive, it will be R plus JX. Where X is XL minus XC. Okay? Then from there you find R and then find XL, XC and then find C. I mean, what we will do is we'll directly start solving it, then you will understand. So please write down the solution. Now, what is given to you? V. V is given as 400 sine 3000 T minus 10 degree. Right? What's the standard form? Vm sine omega t plus or minus phi. What is I given as? 10 root 2 cos 3000 T minus 55 degree amperes. Now tell me how to convert it into standard form. Sine theta plus 90. So it will be 10 root 2 sine, I mean you will add over here plus 90 degrees. 3000 T plus minus 55 plus 90 will be plus 35, right? This is the standard form. So have we solved this type of a numerical? Standard form, you need to convert into polar form. What is polar form? What is polar form for V? Polar form for V. How you get it? So polar form is V angle phi. What is this V? V RMS. I, polar form is I angle phi. What is this I? I RMS. Got it? This is in the form Vm sine omega t plus phi, na? And this is in the form Im sine omega t plus phi. Here phi is minus 10, here phi is 35. Are you getting it? Now please listen. We need to calculate what is Vrms given by. Yes, Vm by root 2. What is Vm? 400. 400 by root 2. That will be 282.84. Please check the answer. Yes. Then calculate IRMS. IRMS is 10 directly. Just wait. Yeah. What will be IRMS? Im by root 2. So 10 root 2 divided by root 2, that will be 10 amperes. Now write down the standard polar form V. So V bar will be what? 282.84. What is the angle? Minus 10 degree, right? You know phi, this is phi now, minus 10. Similarly, what will be I? 10 angle 35 degree. Are you getting it? Why we require V and I? Because we want circuit impedance Z. So Z will be, see, V will be I into Z. So what will be Z given by? V by I. So please substitute it over here. So 282.84 angle minus 10 divided by 10 angle 35 degree. So what happens to angle when they are divided? They get subtracted. So this will be 28.284 angle 45 degree ohms. Now what will you do with this Z? Convert it into polar form, rectangular form. So how will you convert it into rectangular? Shift rect 28.284 comma minus 45. What is it? What you get? 20 minus J20. Did you get 20 minus J20? Yeah. Now this is resembling which form? This is Z bar equal to R minus J X. Capacitive nature है ना? So what will be X? XC minus XL. Okay? Because it is minus, the circuit nature is capacitive. So from here, write down the value of R. What will be R? 20 ohm. What will be X? XC minus XL. That is 20 ohm. Do you know the value of XL? 2 pi. No, we can find that because L value is given now. So it will be 100 pi. No, sorry, not 100 pi. Sorry. No. This is wrong. XL will be omega L, right? What is omega given as? Omega is 3000. Don't go in the flow 2 pi FL. तो ढूंढते रहोगे frequency कितना है? You can do that. Can you compare the standard form of this value? 3000 na omega. So omega is 3000. So substitute. This is equal to 3000. What's the value of L given as? 0.01. So how much is this? 30 ohms. Now can you calculate XC? So XC will be X plus XL. That will be 20 plus 30. That will be 50 ohms. Once we know the value of XC, can you find C? Yes. How? Xc will be 1 upon omega c. So c will be 1 upon omega xc. So 1 upon 3000 into 50. So calculate c in microfarad. Calculate c in microfarad. How much it is? 6.67. The value of the capacitor will be 6.67. Did you get that? Any doubt, anyone? There is one more way of finding this, but that is fine. Completed? Yeah. So we end the lecture over here. One more numerical is there. That I will give it to you as a home assignment. I'll give it a solution also, but don't watch the solution. Try to solve it on your own. All right? And okay, so that's it for today.